Dear students, let us solve the problem on verifying the properties of systems for the discrete time systems. Now this question I had taken here, for the following discrete time systems, determine whether the system is linear, time invariance, memoryless, causal, stable. First question is y of n is equal to n into x of n. Next is y of n is equal to x of minus n. Third one is y of n is equal to log of modulus of x of n to the base 10. Fourth one is 2 into x of n plus 1 divided by x of n minus 2. Now let us take the first one. Y of n is equal to, that is x of n. Sorry, n into x of n. Now when input is x1 of n, output y1 of n is equal to n into x1 of n. When input is x2 of n, second signal, then output y2 of n is equal to n into x2 of n. When the input is sum of the two signals, that is x1 of n plus x2 of n, then output y of n equals to n into x1 of n plus x2 of n. Okay, then that is y of n is equal to n into x1 of n plus n into x2 of n. This is nothing but y of n is equal to, this is y1 of n plus this is y2 of n, and so it is satisfying the principle of superposition, and system is said to be linear. Next, for time invariance. To say it is time invariant, that is y of n is equal to that is n into x of n. To check for the time invariance property, put n is equal to n minus n naught. Then you will get y of n minus n naught is equal to n minus n naught and x of n minus n naught. See here, output is delayed by n naught units, input is also delayed by n naught units, but here n is also delayed by, that is changed by n naught, n is changed by n minus n naught, and you can say that this is y of n minus n naught is not same as the that is t of x of n minus n naught, because here when operation is done on the input signal, that is not same as the output, that is a delayed version of the output. Hence it is, you can say that time variant. So it is a time variant. Next, you should say that whether the system is memory or memoryless. Y of n is equal to n into x of n. Here output depends upon the present values of the input, and system is said to be memoryless. Okay, for example, you can take n is equal to 1, y of 1 is equal to 1 into x of 1. It depends upon the present value of the input, and system is said to be memoryless. Next, causal or non-causal. Here in this case, output depends only on the present values of the input. It is not depends upon any future values of the input, and the system is said to be causal. Here output does not depend on future values of the input. Hence system is causal, and we need to check it is memory. Then we need to check it is stable or unstable. Here y of n is equal to n into x of n. If input is bounded, output also must be bounded. Then only we'll say that it is stable. That is, for modulus of x of n, when it is less than or equal to bx less than infinity, then y of n must be less than or equal to, that is n into x of n, that must be equal to n into x of n. So that must be equal to less than or equal to modulus of n is n, that is less than infinity. Here, as n tends to infinity, y of n will become infinity. Y of n also tends to infinity here. Output tends to infinity. Even though your input is bounded, when n tends to infinity, output y of n will tends to infinity, which is unbounded, which is unbounded. Hence it is unstable system. Hence the system is unstable. Okay. Next, we'll take the second problem. Second problem here is y of n is equal to x of minus n. That is y of n equals to x of minus n. To check for the linearity, that is y1 of n is equal to x1 of minus n, y2 of n is equal to x2 of minus n. Replace x of n by x1 of n plus x2 of n, then y of n is equal to, I need x of minus n here, that is what is required, that is x1 of minus n plus x2 of minus n. This is nothing but y of n is equal to y1 of n plus y2 of n. Hence system is said to be linear. It's satisfying the principle of superposition. System is said to be linear. Next, it is time invariant or variant. Here y of n is equal to, you have y of n is equal to x of minus n. To check for the time invariance property, just put n is equal to n minus n naught. You get, that is y of n minus n naught is equal to x of minus of n minus n naught. That is nothing but y of n minus n naught is equal to x of minus n plus n naught. Okay, that is, here it is not in accordance with the delay in the input signal. That means you can say that it is y of n minus n naught is not same as the t of x of n minus n naught. Hence it is a time variant system. It is time variant system. Next, memory or memoryless here. Here y of n is equal to x of minus n. Suppose if I take that n is equal to 3, n is equal to 3, then we get y of 3 is equal to x of minus 3. See, here output depends upon the past values of the input. It is not depends only on the present values of the input. It depends, see, when observing at n is equal to 3, it required what was there at n is equal to minus 3. Hence it is a memory system. Okay, hence it is a memory system. Okay, causal or non-causal. Here output depends upon the past values of the input. It does not depend upon the future values. Hence it is causal system. For example, if we take x of n is equal to n into x of minus n, take n is equal to 5, y of 5 is equal to, you will get, that is, sorry, y of n is x of minus n, that is, you will get x of minus 5. It depends upon the past values of the input. Here output depends on past values of the input. Hence it is a and you can check for the negative values. Here it output is depends upon the past values of the input. Suppose if we take that n is equal to minus 5. In this case, y of minus 5 is equal to x of minus it will become plus 5. In this case, when n is minus 5, it depends upon the future values of the input. When n is plus 5, it is depends upon the past values of the input. Here you can say causal, but here you cannot say it is causal. Okay, because it here n is equal to minus 5, it requires a value what is there at n is equal to plus 5. That means here it depends upon the here output here output depends on here output depends upon future values of the input, future values of the input. Hence we cannot say it is causal here, hence it is a non-causal system. It is a non-causal system. Next, it is stable or unstable. Here, when x of n is bounded, when x of n is bounded, okay, if then output is also bounded here, y of n is equal to x of minus n. This is less than some value, less than infinity, and it is a bounded system. Then you can see that it is a stable system. You can say that it is a stable system. Okay. Next, third problem, y of n is equal to third one, y of n is equal to log of x of n modulus of x of n to the base 10. Here, to check for the linearity, y1 of n is equal to log of modulus of x1 of n to the base 10. That is, y2 of n is equal to log of modulus of x2 of n to the base 10. Then replace x of n by, that is, x1 of n plus x2 of n. That is, y of n is equal to, it is log of modulus of x1 of n plus x2 of n.